Hi everyone, myself Dr. T. Siva Nageswara Rao, working as Assistant Professor of Mathematics in the Department of Mathematics and Management Science. In previous classes, already we discussed about for a given square matrix, how to find eigenvalues, eigenvectors. For finding eigenvalues and eigenvectors from the given matrix, we will write the characteristic matrix A minus lambda I. The order of the identity matrix is depending upon order of the given matrix. After taking characteristic matrix, we will find its determinant. We will call it as characteristic polynomial. After finding characteristic polynomial, we will equate it to 0. We will get the roots of the characteristic equation. The roots of the characteristic equation is called eigenvalues. Corresponding to each eigenvalue, we will find the eigenvector by using the equation A multiplied with capital X is equal to lambda multiplied with the capital X. By using this equation, we will find eigenvectors. In view of Ax is equal to lambda x, by substituting the respective values of capital A, capital X as column vectors, in which the column elements as x1, x2, x3. Lambdas are the respective eigenvalues. After writing this equation as Ax is equal to lambda x as A minus lambda I multiplied with x is equal to 0, by applying row transformations on LHS side matrix, we will get the echelon form. Based on that, we will find rank of the matrix. If rank is equal to number of unknowns, you will get trivial solution. But unfortunately, in view of eigenvectors, it never becomes zero vector. So, always you will get rank is less than the number of unknowns. Now, this is the process how to find eigenvalues and eigenvectors we discussed in earlier. Together with this, we discussed two different model questions. For distinct eigenvalues, how to find the eigenvectors. For repeated eigenvalues, how to find the eigenvectors. And in one more lecture video, I explained how to diagonalize the given matrix capital A. In two different model questions, I explained one is repeated eigenvalues and one more is distinct eigenvalues. In view of diagonalization, the procedure is after finding eigenvectors, we will write the model matrix capital P, in which the column vectors as eigenvectors corresponding to the eigenvalues of the given matrix capital A. After writing capital P, we will find P inverse. Later, we will write P inverse into A into P is equal to capital D. Now on right hand side, you will get capital D. Capital D is a diagonal matrix in which the eigenvalues, in which the diagonal elements are the eigenvalues of capital A. This is about diagonalization. Now, today we are going to discuss about last topic in unit 2. That is, these are the contents we discussed earlier. Today I am going to discuss about Cayley Hamilton theorem. Cayley Hamilton theorem. Cayley Hamilton theorem. Later I will explain what are the applications of Cayley Hamilton theorem. The applications of Cayley Hamilton theorem is, it is useful to find inverse of the given matrix if det is not equal to 0, and later we will discuss how to find power of a matrix. By using Cayley Hamilton theorem, we can find a power 4, a power 5, a power 6 and so on. So, I will discuss Cayley Hamilton theorem and its applications. And one more topic is the properties of eigenvalues. The properties of eigenvalues and eigenvectors. These are the topics I am going to discuss now. Now, what is Cayley Hamilton theorem? The statement is every square matrix satisfies its own characteristic equation. It means what? If you want to know whether Cayley Hamilton theorem is applicable or not, first of all we need to take square matrix. After taking square matrix, we will find characteristic matrix, determinant of characteristic matrix. You will get the characteristic polynomial involving lambda. We will equate it to 0. That is, you will get characteristic equation. In place of lambda, we are going to replace capital A. Then this characteristic equation becomes matrix equation. By taking matrix equation, we will take only LHS part. LHS part seems to be matrix polynomial. If the given matrix of order is 3 by 3, you will get matrix polynomial of order 3 involving lambda. We will replace lambda with capital A. So, you will get a matrix polynomial of order 3 in which it contains, in place of lambda we will have capital A. So, it looks like some constant multiplied with a cube plus or minus some constant multiplied by a square plus or minus some constant multiplied by a and the constant term multiplied by I. Here what is I? The order of the identity matrix depending upon the given matrix order. If it is 3 by 3, we will write I3. 1 0 0 0 1 0 0 0 1. So, the step-by-step process is take the square matrix, write its characteristic equation involving lambda. In place of lambda, we will replace capital A. We will get a matrix equation. Take LHS. That means you will have matrix polynomial involving capital A. From A, calculate A square, calculate A cube. In matrix polynomial, anyway you have I. I means the identity matrix of order 3 by 3 if the given matrix capital A is of order 3 by 3. If it is 2 by 2, capital I is 2 by 2 identity matrix 1 0 0 1. After substituting I value, A square value, A cube value into the matrix polynomial, by simplifying this matrix polynomial, finally you will get 0 matrix of order 3 by 3 if the given matrix capital A is of order 3 by 3. If capital A is of order 3 by 3, you will get finally 0 matrix of order 2 by 2. It means what? Whenever you are taking the characteristic equation by replacing in place of lambda with capital A, you will get matrix equation. On RHS side, the matrix equation contains 0. 0, it is not actually 0, it is O. O indicates 0 matrix. Previously, we will take LHS side, we calculated A square, A cube, substituted in it. If you are getting 0 matrix, on RHS side 0 matrix, LHS side 0 matrix, therefore LHS is equal to RHS. It means we verified Cayley Hamilton theorem statement. Now again I am repeating the statement. Every square matrix satisfies its own characteristic equation. Own means the characteristic equation or matrix equation derived from the given matrix only. So this is what we are going to discuss now. I will discuss with one example. In this example, you can see at a time verification of Cayley Hamilton theorem, how to find inverse of the matrix, how to find power of a matrix. Together with this, I am going to explain one more application, how to simplify higher degree matrix polynomials into a simpler form. Now the problem is, verify Cayley Hamilton theorem for the matrix capital A of order 3 by 3, 2 1 1, 0 1 0, 1 1 2. After verification, we will find inverse and a power 4 of this given matrix. And if you are observing this matrix polynomial, this is a matrix polynomial of order 8. Manually, if you want to simplify this matrix polynomial, at least it will take minimum 2 hours. Why? Because you need to find a power 4, a power 5, a power 6, a power 7, a power 8. For this finding power of a matrix, it will take a lot of time. Just by using Cayley Hamilton theorem, we can able to simplify this matrix polynomial very easily. Now I will start capital A, just only for verification of Cayley Hamilton theorem. Take the matrix capital A, 2 1 1 0 1 0 1 1 2. Now we will write A minus lambda I. This is characteristic determinant of characteristic matrix equal to 0. This implies 2 minus lambda 1 1 0 1 minus lambda 0 1 1 2 minus lambda is equal to 0. By finding determinant of this matrix, characteristic matrix, we will get the characteristic equation. The characteristic equation is minus lambda cube plus 5 lambda square minus 7 lambda plus 3 is equal to 0. We will replace in place of lambda with capital A. So what you will get? Minus a cube plus 5a square minus 7a plus 3 multiplied with I is equal to O. O is 0 matrix. Now this is what we calculated. Matrix equation. Anyway, we calculated matrix equation. I am going to consider LHS part. Now what is LHS part? Minus capital A cube plus 5 a square minus 7 a plus 3 I. Now I am going to find a square value and a cube value. Anyway, capital A is given. I is identity matrix of order 3 by 3. So what is a square? A square is a into a. Its value is 544,010,445. This is a square value. Now a cube is a square multiplied with a. The resultant answer is 14, 13, 13, 0, 1, 0, 13, 13, 14. This is a square value and a cube value. Now I will substitute this into matrix polynomial, that is minus a cube value. 14, 13, 13, 0, 1, 0, 13, 13, 14 plus 5 multiplied by 5, 4, 4, 0, 1, 0, 4, 4, 5 minus 7 into the given matrix 2, 1, 1, 0, 1, 0, 1, 1, 2 plus 3 multiplied by 1, 0, 0, 0, 1, 0, 0, 0, 1. Now by simplifying this whole matrix polynomial, finally you will get answer as 0, 0, 0, 0, 0, 0. This is LHS value of the matrix equation. Now what is RHS value? 0. That is O, 0 matrix. Hence LHS is equal to RHS. It shows Cayley Hamilton theorem is verified. Now I am going to explain how to find inverse of the matrix. How to find inverse of the matrix. Clearly, the determinant of A is equal to 3, not equal to 0. Hence, A inverse will exist. A inverse will exist. Now, how to find the A inverse? Again, here we will take matrix equation. The matrix equation is minus A cube plus 5A square minus 7A plus 3I is equal to O, 0 matrix. Anyway, det A not equal to 0, A inverse we can find. On both sides of this matrix equation, multiply with the A inverse on both sides. That is A inverse and multiply with the A inverse. Then what you will get? Minus A square plus 5A minus 7I plus 3 into A inverse is equal to O. Now make subject as A inverse. Here A inverse is equal to 1 by 3 multiplied by A square minus 5A plus 7I. Here we will substitute what is the given matrix, capital A multiplied by I. Anyway, we calculated A square value previously. Substitute this value here. And I is identity matrix of order 3 by 3. And simplify this expression. Then you will get A inverse as 1 by 3 multiplied by 2 minus 1 minus 1, 2 minus 1 minus 1, 0 3 0, minus 1 2. This is how we will find inverse of the matrix by using Cayley Hamilton theorem. In generally, what is the process of finding A inverse? A inverse is equal to adjoint A divided by det A. How to find adjoint A? The transpose of the cofactor matrix. What is cofactor matrix? We will derive from the minor matrix. So this is the procedure how to find inverse of the matrix in generally. But here we are not at all doing, or we are not at all finding any minor matrix, its transpose, cofactor matrix, adjoint matrix, etc., etc. So without finding adjoint matrix, just by using matrix equation, we can able to find out very easily inverse of the matrix by using Cayley Hamilton theorem. Next, I will explain how to find power of the matrix. Here our aim is to find A power 4. See, you people can think, anyway we need to find A power 4. We know anyway already A cube. Just by multiplying A cube with capital A, we will get A power 4. Of course, it is correct. But if you have higher order powers, if you want to find, assume that if you want to find A power 10, it will take a lot of time. So instead of finding A power 10 by multiplying with A 10 times, by using Cayley Hamilton theorem, it is very easy to find power of the matrix. In view of power of the matrix, again we will take the matrix equation. What is matrix equation? Minus A cube plus 5A square minus 7A plus 3I is equal to O. Anyway, we want A power 4. So on the both sides of the matrix equation we will multiply with capital A. Then what you will get? Minus a power 4 plus 5 into a cube minus 7 into a square plus 3a. On other side, 0 matrix multiplied by capital A, you will get 0 matrix. So I will make subject as minus a power 4. Therefore, I will write a power 4 as 5a cube minus 7a square plus 7a square minus 3a. Here, a power 4 is equal to 5 multiplied by, anyway, previously we calculated a cube value. Here substitute. What is a cube value previously we calculated? 14, 13, 13, 0, 1, 0, 13, 13, 14. Plus 7 into a square. A square is 5, 4, 4, 0, 1, 0, 4, 4, 5. Minus 3 multiplied with A. What is the given matrix? Capital A, 2, 1, 1, 0, 1, 0, 1, 1, 2. Now, simplify this whole expression. Then you will get a power 4. Now, what is a power 4? The answer is 41, 40, 40, 0, 1, 0, 40, 40, 41. So this is the process how to find power of the matrix. So now we completed how to verify Cayley Hamilton theorem. By using Cayley Hamilton theorem, how to find inverse of the matrix and power of the matrix. Now one more application is using Cayley Hamilton theorem, we can able to simplify the matrix polynomial. Now what is the given matrix polynomial? A power 8 minus 5 into a power 7 plus 7 into a power 6 minus 3 into a power 5 plus a power 4 minus 5a cube plus 8a square minus 2a plus I. Manually, if you want to simplify this, you need to calculate a power 5, a power 6, a power 7, a power 8. So for finding these powers of this matrix, it will take lot of time. Just by applying Cayley Hamilton theorem, we can able to simplify this matrix within few minutes. So how to simplify? Right, before going to simplify this, first of all, we will write what is the matrix polynomial we written earlier. What is the matrix polynomial we written earlier? Or matrix equation we written earlier? A cube minus 5a square plus 7a minus 3i is equal to 0 matrix. Just by taking minus as common on both sides. Just we will use this in way of simplifying this matrix polynomial. Now, first take these 4 terms. Take out a power 5 as common from it. That is a power 5 a cube minus 5a square plus 7a minus 3i plus a power 4 minus 5a cube 8a square minus 2a plus I. If you are observing this expression, a cube minus 5a square plus 7a minus 3i, what is its value? 0 matrix. Now 0 matrix multiplied by a power 5. 0 matrix multiplied by a power 5. hence it becomes 0. Now the remaining polynomial is a power 4 minus 5a cube 8a square minus 2a plus I. Now try to understand one thing, why I am taking a power 5 as common from first 4 terms, because if I are taking a power 5 as common, then the remaining expression looks like a matrix polynomial of degree 3. It is same as the characteristic matrix equation. Now we are going to simplify this. How? A power 4 minus a cube plus 7a square plus a square minus 2a plus I. Here just I am writing 8a square as 7a square plus a square. Now from these 3 terms I am going to take out a square as common. Then what you will get? A square multiplied by take out a square as common. This is a square. Sorry. Take out a as common, not a square. A cube minus 5a square plus 7a plus a square minus 2a plus I. Now from this equation, what is a cube minus 5a square plus 7a? Simply it is 3i. So a into 3i plus a square minus 2a plus I. Now simplify this. What you will get? A square. Here it is 3a and here it is minus 2a. Then what you will get? Plus a plus I. See here the beauty of matrix equation of order 3, reducing 8th degree matrix polynomial into 2nd degree matrix polynomial. If you want to simplify this expression, it is same as the simplification of 8th degree matrix polynomial. Anyway, here we will substitute a value and a square value. Then what you will get? The final answer is, what is a square value? A square value is 5 4 4 0 1 0 0 3 0 5 5. A square value 0. This is 1 4 4 5 plus the given matrix here and identity matrix of order 3 by 3 1 0 0 0 1 0 0 0 1. Here what is A? 2 1 1 0 1 0 1 1 2. Just by adding all these, you will get answer as 8 5 5 0 3 0 5 5 8. So this is the final answer for simplification of the matrix polynomial of order 8. Here we are not calculating power of the matrices like a power 5, a power 6, a power 7, a power 8, a power 4, a cube also. Just previously we calculated a square, just we are substituting its in place of it and simplifying it. You will get the final answer. This is the advantage of Cayley Hamilton theorem in view of simplification of the matrix polynomial. Next, I am going to explain properties. Before that, I given worksheet. Please practice all these problems. Together with this, I already given answers for these problems. I given 3 problems. First 2 problems are verification of Cayley Hamilton theorem and finding power of the matrix. And third problem, I gave 2 by 2 matrix. I given 2 by 2 matrix of 2 by 2 matrix. Just simplify the matrix polynomial. So please practice all these questions. So till now we completed statement of Cayley Hamilton theorem, verification of Cayley Hamilton theorem, the applications of Cayley Hamilton theorem as to find inverse, power of a matrix, and simplification of matrix polynomial. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.